I'm Patrick Megar. I'm technical sales specialist for IBM Process Mining. So we are going to start with an overview of IBM Process Mining, and then I will go through a demonstration that is coming from a real use case in the bank area. So first, so the data is coming mostly from the systems that are part of the business processes, such as SAP, Salesforce, proprietary application, and so forth. And so we need to extract those data from those systems in order to create an event log that will be taken as the input file for doing process mining. So from this event log, and I will come back to that, we will get three different part of process mining, which are discovery, analytics, and what we call the digital twin to do simulations. So alternatively to system logs, and this is very important, we can also do task mining, which is about recording the user actions while they are performing their daily job. From this information, we will be able to determine some automation strategies such as RPA bots or other kind of automations. So we can combine both the IT system data and the data coming from recording the user actions, which is task mining. So I will come back to that very deeply in the demo, but so we start trying to discover what are the business processes that we are mining, to kind of understand, where we are finding bottlenecks, where there are reworks, where we are waiting too much time, and so forth. Then we can go to the analytics, where we are going to create a series of dedicated dashboards that will be used by the business owners to really track the daily progress of the processes. And finally, the digital twin, which is actually the model of the business processes that is mined. The goal here is to create some 2B scenario, to simulate those scenarios, to determine the impact, the ROI of those scenarios, to redefine what is the automation strategy that we should conduct. So the use case that I'm going to illustrate with the demo is coming from a real client, Credito Emiliano. This is a bank, and they had a problem with a series of business processes. So one of them was the process of closing a bank account. Unfortunately, so they have quite a lot of bank account demands, and unfortunately they were not able to comply with the European regulation that are requesting that any bank account should be closed within 12 days. So this was resulting in problem with compliancy, but also with dissatisfaction from clients. They also decided to go further and deeper and to use also task mining in combination with process mining to really understand very finely what are the user tasks and where they could really save time. And so the combination of process mining and task mining in this project led them to save up to 20%. So as I said before, we need to log what we call an event log that has been prepared in advance using some typical ETL approaches, such as IBM Data Stage, such as Talent Software, SPSS Modeler. I mean, there is a huge list of ETL tools and practices, and so we are just using those kind of very standard practices to create the event log from the IT systems. So here we have the resulting event log that was created with IBM Data Stage. We need to have something that identify each case. So here it's a request ID, which is a request for closing a bank account. The activity, which represents each step of the process, and the start date. So to do that, I mean, we just need to map. So we select a column and we map that to the corresponding model in process mining. Then we can have end date, resource, and row that are optional. And what is very important is that we can have any number of additional custom fields that will be used to provide contextual data in any kind of types. So when we have mapped the event log, we can visualize the process. And the result of visualizing the process is to compute, the graph that is resulting from those events, and to provide some very insightful visualization. So here, for instance, we can see that the process starts with the creation of the request, and then it can go to evaluating the request or even deleting the request. So here we have the graph of all the events. So the dark boxes show activities that are occurring a lot. When it's lighter, those activities are less frequent. So here, you have 1,359 occurrence, and here you have something like 116,000 occurrence. So in this event log that was loaded in a few seconds, we have 116,000 cases and 730,000 events. So this is a frequency view. We can also see the bold relationship, which are showing the transition between activities. So this is a simplified view. Obviously, the reality is more complex, and if we wanted to zoom into all the possible relations and activities, we would have something that looks like a spaghetti plate, which really shows the reality. So in order for the analyst to get a clearer picture, we can reduce the number of relations, which doesn't filter out any events, but provide a more simplistic view. We can also look at the variant view. So here what we can see is a series of variants that the cases are following. So we can see here that 27.8% of the cases are taking the first variant, and this first variant includes 7 activities, and in average 19 days. So when we select this variant, we remove all the activities and transitions that are not part of the variant to see more clearly what is the happy path, let's say, of this variant. We can select another one. We can also select several variants and so forth. So typically, when planning an automation implementation, we would probably focus on the variants that are the most frequent, because those are typically the ones for which there will be the maximum impact. All right. Something that is also very interesting is to compare those processes with what we call a reference model. So typically in most companies, we have models that have been created with ARIS, with Works Life, or any kind of modeling tool that represent the theoretical organization of the processes. So here we have loaded a file that is coming from a modeling tool that represents the theoretical process, and we compare that with the reality. So in this situation, we can see that all the red boxes are activities that are non-compliant, which means that they are not part of the reference model, and same thing for the transitions. So this is what we would call deviation. So here we have the list of all the deviation. We can see that 77,000 cases are conformant, but 39,000 are non-conformant. And we can compare the lead time, the number of steps, and the cost of those things. So here we have the list of all the deviations. And for instance, we can see that this deviation represents almost 5,700 cases. And we can look at some root cause analysis. So we have an artificial intelligence engine that can go through all the contextual data to determine whether or not he can find some reasons for this deviation. So here we can see that he found 2 reasons, one which is not probably significant, and the other one that is strong, and that shows that the closure type, the closure reason, and the working state are explaining the occurrence of this deviation. The average duration view is very interesting, as we can easily see the duration of each task, as well as the duration of each transition, or the waiting time between 2 activities. With this information, the business analyst can easily detect the transitions or the activity duration that are way too long compared to the expectations. In this particular bank account closure example, the analyst saw that the back office service closure activity is taking 52 hours and 44 minutes. Similarly, the pending request for network information took 118 hours and 20 minutes. To better understand what's happening, we used task mining and we recorded the actions of the employees during this activity through the installation of an agent. Task mining then creates a new process mining project that finally describes all the tasks. Now we can drill down into back office service closure to see the corresponding project that was generated by task mining after having recorded the activity of the employees. So now we see that one task is to take in charge the demand, then to revoke the credit card, and so forth. All those tasks were not visible through the event log that we collected from the IT systems. That's why task mining can be very interesting. We get also access to the duration view, where we can see the waiting time or the duration of each activity, and to the variant view. So here we see that 50% of the cases were taking one particular variant, which is probably the best candidate for automation, because this is where we will have the biggest impact. If we go to the analytics view, we will see other very interesting details that were collected from task mining. So here we have a table showing all the tasks, and for each of them we measure the productive time, the idle time, and the time spent on other tasks. So the productive time is really the time that we can gain if we do some automation. Idle time corresponds to activities on the computer, but that are not related to this business activity. And the time spent on other tasks corresponds to anything else that the employee is doing before completing the business activity. That can be a phone call, that can be any kind of activity. So the reality is that out of those 52 hours, we can really save something like 2 hours of productive time. And so it's very important to set the expectations correctly before starting an automation project. We can now come back to the original project to discover the filtering capabilities. To create a new filter, we open a specific dialog where we can, for example, select all the cases with an activity back office service closure that is starting the case. Now we have selected 79 cases that were started with back office service closure. This is probably coming from the fact that we recorded the events after those cases were really started. So we are missing some events. Let's remove this filter. What I would like to do now is to only select the cases that are completed. So I want to exclude all the running cases. Let's now see the Bpmn view. The Bpmn model is generated from the event log. So we can see the starting point, the end point, and the various swim lanes that correspond to the roles which are performing the activities. We also get access to the rules mining to automatically discover the business logic that is being used within each gateway. This is using the contextual data to determine really the business reason for going to the left or to the right of a particular gateway. The dashboard view gives statistics of all the cases, like the number of cases per day, the average duration, and the list of all the activities with some details. Now that we have done task mining, we can get access to a recommendation view for RPA candidates. If you remember well, we did task mining for network service closure, pending liquidation request, back office service closure, and evaluating request. What we would like to know is what's the best way to get a good return on investment if we implement RPA bots. So for this, we need to set a target. So the target that we want here is to achieve 50% of automation for all the cases. And we would like that the bot complexity is low, which means that we would want to just implement one variant. What the tool tells us is that for those goals, only back office service closure is a good candidate. So here, if we implement a bot that automates one variant, we will achieve 50% of cases that are automated. If we now decide to increase a little bit the complexity of the RPA implementation, we can see that network service closure would enable automating almost 70% of the cases by just implementing two variants. So here we would have an additional choice. So let's now simulate this to-be scenario to see whether or not we should proceed with this automation strategy. The simulation view, also called the digital twin, gives access to several parameters. We can modify the business hours, the start date. I could change the number of cases that I want to generate. We can change the arrival distribution that could be historical or maybe exponential or logarithmic or uniform. Now we want to change the parameters of the activities to define the to-be scenario. The tool automatically made some changes for network service closure and for back office service closure, which are the two business activities that were proposed to be automated. So for the first one, if we look at the RPA tab, we can see that by using one RPA bot, we can achieve 69% of cases that are automated. It would be interesting to probably modify some parameters that the business analyst will have to determine. For example, if more than 50% of the cases are automated, probably the human will have to wait less to do their job. So I will reduce here significantly the number of hours where the cases are waiting for someone to be available. Same thing for back office service closure. The system recommended at least two bots, so that's a parameter of the system, to achieve 50% of the cases automated. And again, it would be a good idea to modify a little bit the waiting time because obviously you have more you still have the same number of people, but you have bots that are doing half of the tasks. Okay, so we could do other changes, such as modifying the Bpmn model, for example, but I will stay on that. So now let's run the simulation. So the simulation engine will generate 1,000 events using those parameters. And then we will be able to compare the as-is scenario with the to-be scenario to decide whether or not it's worth doing this kind of automation. So what we can see here is that the as-is scenario is in average taking 19 days to complete a case. And with those two automations, we achieve 14 days. So that's a significant improvement. We would need to refine the simulation to be able to reach the 12 days required by the regulation. This is ending my demonstration. Thank you very much.